At 4:23 a.m. on a Tuesday morning in Tula Oblast, Shift Supervisor Anatoly Petrov monitors Building 12 of the Degtyarev plant, 135 miles south of Moscow. This facility produced 12.7 mm heavy machine guns at a rate of 80 units per month. Computer-controlled milling machines shape receiver blocks from steel billets. Assembly stations line the walls, where technicians fit barrel assemblies and firing mechanisms. This single building represents $42 million in precision manufacturing equipment. The machines on this floor produce weapons that equip Russian armored vehicles, fortified positions, and vehicle-mounted systems across the entire front line in Ukraine. Destroy this building, and you eliminate 12% of Russia's heavy machine gun production capacity. Petrov checks the security logs. A Tor M2 air defense system sits on the north perimeter, its radar scanning the sky every 3.8 seconds. Electronic warfare jammers create a protective bubble that disrupts GPS signals within 8 kilometers. Security cameras cover every approach. Armed guards patrol in pairs. On paper, nothing gets through. But at 4:31 a.m., something crosses the outer security perimeter that none of these systems were designed to stop. Ukrainian intelligence has been studying the Degtyarev plant for 7 months using social media. Workers at the plant post photos from their shifts, pictures of completed machine guns, shared with pride, videos of quality control testing, filmed on personal phones, complaints about overtime schedules that reveal which buildings operate night shifts, geotag posts from the parking lot that map exactly where people enter and exit. The intelligence team doesn't need classified satellite imagery. They have hundreds of data points from the workers themselves. They know Building 12 runs a night shift. They know the shift change happens at 6 a.m. They know the building's ventilation system pulls air through massive intake vents on the eastern wall. And they know something the facility's security planners don't. Those ventilation vents are a vulnerability that costs $42 million to exploit. The attack package consists of 12 drones. These are long-range reconnaissance drones modified for deep penetration missions. Each one has a range of 400 kilometers. Each carries 3 kilograms of thermite-based explosive. Each costs approximately $4,000 to build. Total investment for the strike, $48,000. The drones launched from Ukrainian territory 6 hours ago. They didn't fly directly toward the target. Instead, they flew in a wide arc, staying low over forested areas where radar coverage is inconsistent. They navigated using terrain-following algorithms that kept them below 100 meters altitude, hugging valleys and riverbeds. At several points, they landed in pre-scouted locations, powered down completely, and waited while Russian air patrols passed overhead. By 4:28 a.m., all 12 drones are in position, orbiting 3 kilometers from the Degtyarev plant. They're flying at 90 meters altitude, slow enough that the Tor M2 radar classifies them as birds or atmospheric clutter. The system is optimized to detect threats moving at 200 meters per second or faster. These drones are traveling at 23 meters per second. At 4:31 a.m., the attack begins. The first wave consists of 3 drones targeting the facility's electronic warfare systems. These systems are powerful, capable of jamming GPS and radio frequencies across a wide area. But they're also electromagnetic beacons, broadcasting their location with every jamming pulse. The Ukrainian drones don't need GPS. They navigate using visual recognition, their cameras matching real-time images against preloaded reference photos. The first drone impacts the primary EW antenna at 4:31 and 42 seconds. The thermite charge burns through the antenna's feed line, severing the connection between the transmitter and the broadcasting element. For 8.3 seconds, while backup systems attempt to reroute power, the jamming bubble collapses. In those 8.3 seconds, the remaining 11 drones update their targeting data via encrypted radio burst transmissions. They confirm Building 12's location. They verify the ventilation intake positions. They finalize approach vectors. The second and third drones from Wave 1 hit the backup EW systems before they can fully activate. Within 18 seconds of the first impact, the facility's entire electronic warfare capability is offline. Inside the security center, Alarms are screaming. Monitors show the EW systems going dark, one by one. Petrov receives an emergency alert on his radio. He orders the facility into lockdown protocol. Steel shutters begin rolling down over windows. External doors seal automatically. The Tor M2 system switches to active engagement mode, its radar now scanning aggressively for threats. But the radar is looking in the wrong place. It's searching the sky at medium and high altitude, looking for cruise missiles or aircraft. It's not looking at the slow-moving contacts approaching from multiple vectors at building top height. At 4:33 a.m., Wave 2 strikes Building 12. 9 drones approach from 3 different directions. 3 from the north, 3 from the east, 3 from the south. The staggered approach makes point defense nearly impossible. Even if the Tor M2 could track targets this slow and this low, it can't engage 9 simultaneous threats from different vectors. The facility's armed security guards open fire with assault rifles, tracer rounds cutting red lines through the pre-dawn darkness. They manage to hit one drone, sending it spiraling into the parking lot where it explodes, harmlessly. But 8 remain, and they're seconds from their targets. The drones don't aim for the building's walls or roof. Reinforced concrete and steel framing would absorb the impact, limiting damage. Instead, they aim for the massive ventilation intakes on the eastern wall. These vents are critical to the facility's operation. The manufacturing process generates metal dust, chemical vapors, and heat. The ventilation system pulls fresh air in through filtered intakes, circulates it through the production floor, and exhausts contaminated air through scrubbers. The intake vents are protected by metal grills, but the grills are designed to keep out birds and debris, not explosives. At 4:33 and 19 seconds, the first drone punches through the intake grill and detonates inside the ventilation shaft. The thermite ignites instantly, burning at 2,400 degrees Celsius. The metal ductwork becomes a furnace. Molten metal drips onto the filtering systems below. The filters, designed to catch particulates from manufacturing, are made of synthetic materials that ignite at 800 degrees. The ventilation system becomes a delivery mechanism for fire. The second and third drones hit adjacent intake vents. Now flames are spreading through 3 separate ventilation shafts, all feeding into the main distribution plenum above the production floor. Inside Building 12, Petrov sees smoke pouring from the ceiling vents. Not regular smoke, but black, chemical-laden smoke from burning synthetic filters and melting ductwork. The automatic fire suppression system activates, sprinklers drenching the production floor. But the fire isn't on the production floor yet. It's in the ventilation system above, spreading through ducts that run the entire length of the building. The sprinklers are wasting water on machinery that isn't burning, while the actual fire spreads unchecked overhead. The 4th and 5th drones from Wave 2 target the building's electrical transformer stations, gray metal cabinets mounted on exterior walls. The thermite burns through the transformer housings in seconds. Electrical systems overload, circuit breakers trip. The entire building loses power. The CNC milling machines freeze with partially completed receiver blocks still clamped in their fixtures. The assembly line stops. But losing power means losing the computerized fire suppression control system. The sprinklers continue running at default settings, dumping water indiscriminately. But the targeted suppression systems, designed to deploy chemical foam on electrical fires or to seal off specific sections, are offline. The 6th, 7th, and 8th drones hit their targets in rapid succession. 2 more ventilation intakes, one targeting the building's emergency generator housing. By 4:35 a.m., Building 12 is in crisis. Fire is spreading through the ventilation system faster than suppression can respond. Power is out. The emergency generators are damaged and won't start. Smoke is filling the production floor, thick black clouds that reduce visibility to less than 3 meters. Petrov orders immediate evacuation. 83 workers on the night shift begin moving toward emergency exits. The exits open, but now smoke has a path out and fresh air has a path in. The ventilation system, still partially functional despite the fire, begins pulling oxygen-rich air into the burning ductwork. The fire intensifies. At 4:37 a.m., a section of the main ventilation plenum fails. A 6-meter section of ductwork, weakened by fire and loaded with burning filter material, collapses onto the production floor, lands directly on Assembly Station 7, crushing the precision tooling and igniting the hydraulic fluid used in the pneumatic systems. Hydraulic fluid burns hot and fast. The fire spreads to Assembly Station 6, then 5. Within 90 seconds, an entire row of assembly stations is engulfed. The CNC machines, coated in cutting oil and surrounded by metal shavings, become fuel sources. The fire spreads to the quality control area, where completed machine guns sit in storage racks. The machine guns don't explode, the ammunition isn't loaded, but the weapons themselves begin to fail as temperatures rise. Steel components warp, barrel assemblies bend, receiver blocks crack. Even if the fire is eventually controlled, these weapons are scrap metal now. At 4:41 a.m., Petrov stands in the parking lot, watching Building 12 burn. All workers are accounted for, no casualties, but the building is lost. Fire crews from the local station have arrived, but they're not fighting to save the structure anymore. They're fighting to keep the fire from spreading to Buildings 11 and 13, which house ammunition components and explosive materials. The final drone from Wave 2 doesn't strike Building 12. It strikes Building 6, 800 meters away. This building manufactures ammunition feed systems, the mechanical components that move cartridges from belt to gun. The drone hits the building's roof-mounted HVAC system, destroying the climate control that keeps humidity levels precise during manufacturing. The damage to Building 6 isn't catastrophic. It's degradation. Without precise climate control, the manufacturing equipment will produce parts that are out of specification. Not obviously wrong, but wrong enough that they'll cause jamming and failures when installed in weapons systems. For the next 6 months, until the HVAC system is fully repaired and recalibrated, Building 6 will be producing ammunition feed systems that have a 12% higher failure rate than normal. Those systems will be installed in weapons across the entire Russian military. And when those weapons jam in combat, no one will trace the failure back to a single drone strike on a Tuesday morning in Tula. By 6:15 a.m., the fires in Building 12 are contained but not extinguished. The structure is gutted, the roof has partially collapsed, every piece of manufacturing equipment is damaged beyond repair. The precision milling machines, with their computer-controlled systems and calibrated tool heads, are scrap. The assembly stations are twisted wreckage. Russian state media reports an industrial accident at a manufacturing facility in Tula Oblast. Initial reports claim minimal damage. Production will resume within weeks. By afternoon, those reports are quietly revised. The facility will require extensive repairs. Independent analysts examining satellite imagery tell a different story. The thermal signature from Building 12 is visible from orbit. The damage is catastrophic. Reconstruction will take a minimum of 18 months, more likely 2 years. Cost to rebuild, approximately 2.3 billion rubles, roughly $78 million. But the real cost isn't measured in rubles or reconstruction timelines. It's measured in weapons that won't be produced. Building 12 manufactured 80-cord heavy machine guns per month. That's 960 weapons per year. Over 2 years, Russia loses production of 1,920 heavy machine guns. Those weapons would have equipped armored vehicles, fortified positions, helicopter door guns, and naval installations. Without them, Russian military units must either cannibalize weapons from storage, accept gaps in their defensive capabilities, or divert resources from other production lines already operating at capacity. The strategic calculation becomes brutal. Russia can attempt to increase production at other facilities, but those facilities are already maximized. They can purchase weapons from foreign suppliers, but that requires hard currency and reveals capability gaps to potential adversaries. They can reduce allocation to certain units, but that means choosing which forces operate with degraded capabilities. Every choice is a compromise forced by $48,000 in drones and 7 months of intelligence gathered from social media posts. The Degtyarev plant attack demonstrates something fundamental about modern industrial targeting. You don't need to destroy an entire facility. You need to identify and eliminate the specific bottleneck that makes production impossible. Building 12 was that bottleneck. It housed the most sophisticated machinery, the most skilled workers, the most difficult to replace equipment. Ukraine identified it through open source intelligence. They struck it with commercially derived technology. They eliminated $78 million in infrastructure and 2 years of weapons production with an investment of $48,000. The return on investment is 1,625 to 1. If you found this analysis valuable, hit that like button, subscribe, and turn on notifications for more tactical breakdowns of modern military operations. We analyze the strategies, technologies, and innovations reshaping how wars are fought. The lesson from Tula is clear and replicable, and every modern military depends on a network of industrial facilities producing the weapons, vehicles, and equipment that sustain operations. Those facilities represent concentrated value. Destroying them creates cascading effects far beyond the immediate damage. Lost production, delayed deliveries, degraded capabilities, resource reallocation, strategic compromises, and in an era where precision strikes can be executed with commercial technology and open-source intelligence, no facility is beyond reach. The question isn't whether industrial targets can be hit. The question is which targets create the maximum strategic effect for the minimum investment. Russia is learning this lesson facility by facility, billion by billion. Ukraine continues to demonstrate that you don't match an adversary's industrial capacity. You disrupt it. You identify the critical nodes and eliminate them with surgical precision. The Degtyarev plant burned because someone asked, what's the one building that matters most? What's the one target that creates irreplaceable loss? They found the answer, and they removed it from the battlefield with 12 drones and a Tuesday morning strike. What other critical infrastructure becomes vulnerable to this approach? Share your analysis in the comments below.